Infrared proximity sensor. Over time, non-contact sensing has transformed multiple industries, from industrial automation to consumer technology. In this video, we will explore how IR proximity sensors work and their history, the physical principles behind them, and their real-world application. What do they measure? An infrared proximity sensor measures the distance or presence of a nearby object without physical contact. It uses infrared light to detect the reflection of an object and calculate how close it is. History of infrared proximity sensors. The discovery of infrared radiation dates back to 8000s when William Herschel, a British astronomer, conducted an experiment with a prism and discovered a region of electromagnetic spectrum beyond visible light, which are infrared rays. Since then, the infrared technology has evolved. Between 1940s and 1950s, the first IR sensors were for military applications, such as night vision systems. Between 1970s and 1980s, introduction was in industry, with proximity sensors on production lines. Between 1990s and 2000, popularization in consumer electronic devices, such as remote controls and sensors in telephones. Nowadays, we can see them in home automation, robotics, and security. Now, let's see how do these sensors work. The basic structure of an IR proximity sensor is an emitter and a receiver. The emitter is an infrared LED that generates a beam light. The receiver can be a phototransistor or a photodiode, which measures the amount of light reflected. The process starts with the emission. The IR LED emits an invisible infrared light beam. If there is an object in the range of sensor, some infrared light is reflected from its surface. The photodiode or the phototransistors measures the amount of light reflected. If the intensity of the beam light is high, the object is close. If it's low, the object is far away or absent. Now, the capture signal is converted into a voltage proportional to the distance of the object. The output generates a signal that can be processed by a microcontroller or a logic circuit. The distance can be calculated with two methods. The first one, reflected light intensity, where D means the distance of the object and K and C are constants obtained by experimental calibration. Time of light, on the other hand, C means the speed of light, and the difference between T1 and T2 means the time difference between emission and reception. Types of proximity IR sensors. The first type are the direct reflection sensors, which detect light reflected from a nearby object. Closer the object, the more intense the reflection is. The second type, barrier or interruption sensors. They place an emitter and a receiver on opposite sides. They detect interruption of light beam when an object blocks the passage. Why infrared light? Our surrounding is filled with lots of visible colors, and choosing any one of these colors can confuse the sensor. While infrared light is just outside the visible light spectrum and it's near to the red color, which means it has a larger wavelength and the visible light spectrum can travel a good distance without much scattering, hence it will be easier to sense. There are factors that can affect the performance of the sensor, such as color and material. Light colors return more light, which improve detection. Dark colors reduce the sensitivity of the sensor because they absorb IR light. The angles of incidence. If an angle hits the object with an oblique angle, some light may be deflected and not returned to the receiver. Also, external interference can affect the sensor, such as strong light sources, as the sun or incandescent lamps can generate noise in the measurement. There are many infrared proximity sensors available on the market. Some examples are Sharp sensor, which is an infrared sensor widely used in robotics, sensing range from 10 to 80 centimeters with an approximate price of 35,000 pesos or $9. TCRT 5000, an infrared sensor common in line follower robots with an approximate price of 3,000 pesos or 80 cents. E18, D80, and K, a through-B sensor used in industrial systems with an approximate price of 20,000 pesos or $5. Infrared proximity sensors can be found in industry in production lines to detect moving objects, in household appliances such as automatic soap dispensers and non-contact faucets. Also can be found in parking assistance systems in cars. These sensors are also found in security in infrared barriers for alarms and automated access. On mobile phones, when it detects the phone close to our ear and turns off the screen to save battery.